Okay, well last time we proved Young's inequality. Now I'm going to state and prove a generalisation called Hölder's inequality. I'm not sure I'm saying that right. Quality. Well, I'm going to state Young's inequality because I'm going to need it. And Young's inequality says the following, that if 1 over a plus 1 over b equals 1, a and b are positive, x and y are positive, implies that xy is greater than or equal to x to the a over a plus y to the power b over b. That's Young. Now we can generalise that. We can generalise this to Hölder's inequality. And Hölder said that if we've got x1, a sequence of letters x1 to xn, with the xi positive, and sorry, that should be a y1 through yn, yi are positive, and we've also got 1 over a plus 1 over b equals 1, a and b positive. Then Hölder says this, that sigma I equals 1 to n, xi, yi, so the sum of the pairwise products, is less than or equal to the product of two things. It's sigma, again from I equals 1 to n, of xi to the power a, all to the power 1 over a, times sigma I equals 1 to n, oops, where's that got there? Seems to be a bit badly behaved, yi to the power b, all to the power 1 over b. And that is Hölder's inequality. How do we prove this? Well, what we do is we observe that if xi goes to alpha xi, then it's the inequality is still true. Yeah, it's still true because we can scale the x's. If we multiply all the x's, you'll see that we raise them all to the power a, and outside the summation we raise it to the power 1 over a. So it's still true. We can also do the same to the y's. The inequality is still true. Still holds. I guess if and only if it if the inequality held before the scaling. Okay, so how do we use that? Well, what I'm going to do is I'm going to scale so that sigma xi to the power a equals 1 by choosing a suitable alpha. I guess I'll divide by sigma xi to the power a, really. And I'm also going to ensure that sigma yi to the power b equals 1. What can I do now? Now we know that x from Young, we know that xi yi is less than or equal to 1 over a xi to the power a plus 1 over b times yi to the power b for all the i's. Up to n. There we go. And so what we can do now, this is just from Young, so we just sum over i's. Sum, and we get sigma xi yi less than or equal to 1 over a sigma xi to the power a plus 1 over b sigma yi to the power b. All of this, we've got 1 over a plus 1 over b equals 1. Okay, so we've got that. And now I'm going to remind you that we've scaled so that sigma xi to the power a equals sigma yi to the power b equals 1. So this inequality here yields sigma xi yi is less than or equal to 1 over a times 1, because it's 1, plus 1 over b times 1 equals 1 over a plus 1 over b equals 1 by construction. So sigma xi yi is less than or equal to 1. There we go. Okay, so we've got the first bit of the inequality, which we'll need later. Come back to that. And now I'm going to rescale. I'm going to scale a second time So sigma xi to the power a equals a, let's say, and sigma yi to the power b equals capital B. And I'm going to write xi dash equals xi over capital A to the power 1 over a. You'll see why in a minute. And of course I'm going to write yi dash equals yi over b to the power 1 over b. Okay, so I'm just scaling again here. So we know that sigma xi dash all to the power a equals sigma xi to the power a over a, which equals 1 by construction. And I also know that, just a minute, sigma yi dash to the power b equals sigma yi to the power b over b, which again is equal to 1 by construction. Great. So now we ask what's sigma xi dash yi dash. Sorry about that. Yeah, we ask what does sigma xi dash yi dash equal. Well, we know that's less than or equal to 1 because xi dash and yi dash are scaled. They're scaled according to this scale here, and so we know that the sum of the products is less than or equal to 1. So sigma xi dash yi dash is less than or equal to 1. But sigma xi dash yi dash equals sigma xi yi over a to the 1 over a, b to the 1 over b, which equals sigma xi yi over a to the 1 over a times b to the 1 over b, from which we can deduce that, let's get this right, sigma xi yi is less than or equal to a to the 1 over a, b to the 1 over b. And now we may as well just write down what a and b are. We may as well expand that. So that tells us that sigma xi yi is less than or equal to sigma xi to the a to the 1 over a, sigma yi to the power b to the 1 over b. And that's it. That's what we were trying to prove. I guess that's QED. I'll just say what I've gone on longer than I meant to go on for this. It's quite tricky, this inequality. There's quite a lot going on. I want to say that if A equals B equals 2, then what do we get? We get sigma xi yi less than or equal to the square root of sigma x squared times the square root of sigma y squared, and with a little bit of rearrangement, sigma x squared, sigma y squared, greater than or equal to sigma x, y, all squared. We've seen this before. It's Cauchy. That is Cauchy's inequality. So what we see here, this Hölder's inequality here, I may as well write it out again. I'm going to write it out again. Sigma xi yi less than or equal to sigma xi to the power a 1 over a times sigma yi to the power b 1 over b. 1 over a plus 1 over b equals 1. This is a special case of the Cauchy-Schwarz inequality. There we go. But it's a lot more subtle. There's a lot more going on here than in Cauchy's inequality. Yeah, I'm going to stop there.